So write an equation that passes through 2 points, -2, -4, and 4, -7. So this is what you were referring to, correct?
Yes.
So first thing you would do is label. Label your points. I always call my first point I run across x1, y1. Second one, x2, y2. Now, before we create our line or write our equation, we need a slope. Need a slope of the line. So since we do not have that, we just have 2 points. Use the 2 points. Find a slope. So we're going to use those 2 points to find a slope. Your slope formula, y2 minus y1 over x2 minus x1. Y2 is -7. Y1 is -4. So that's -7 minus -4. X2 is +4. And then x1 is -2. All right, so don't forget negative to negative turns positive. So that ends up happening in both the numerator and denominator. So it's -7 plus 4, 4 plus 2. So that's -3 over 6, which is -1/2. So before we go any further, questions on how we got to -1/2? So now we have our slope. So now I can use the slope in either point to find the equation. Slope is -1/2. X1, Y1 was -2, -4. Once again, you could use either point, doesn't matter. So that's y minus y1 equal to m times x minus x1. Let me make more room. All right, so we have y minus -4 equal to -1/2 times x minus -2. So y plus 4, x plus 2. Distribute the -1/2 into the parentheses. So That negative 1/2 times 2 is 2 over 1. So that's negative 2 over 2, which is just negative 1. Then we can finish it off by subtracting 4 from both sides. And y is equal to negative 1/2 x minus 5. Questions on the process?
It just took me several attempts to get it. I don't know if the homework shows how many times a person tries a problem.
I have to take a look because it shows how much time you put in, but I don't think it shows how many times you do a certain problem.
Got you. Can you hear me?
Yep.
Cool. My speaker wire came out. That's why I asked.
No worries. You all good, sir. Are there any other questions before I do anything? Anything anybody want me to review? Type of problem before I go anywhere else?
I do. When I was graphing during homework, it was telling me that I was graphing wrong, but when they put the correct one up there, I had the exact same thing.
Okay. And you didn't pop up because the way my screen is set up. Who is talking?
This is Jennifer.
Jennifer,
I'm
last
sorry, no
names?
picture.
Yeah.
Spence.
Okay. I'm going to look at yours real quick and see if I can see what's going on.
And I'm trying to figure out how to move the screen so I could go to it myself. Okay, here we go. It's under section 5.3 and it's number 3, 5, and 7.
All right. Matter of fact, I think I went to the wrong one. You writing on my screen down there?
My bad.
No, you could, but I'm just messing. Let's see. Exponents. 5.3. You said 3, 5, and 7? Yeah, okay, I see it.
When I had to graph it, it was telling me that it was wrong, but I don't understand how it's wrong when my y-intercept and my x-intercept was both 0 for the ordered pair.
Right. I'm looking at it right now. It looks fine to me. Trying to see if there's anything. Now, well, let me go back. Number 3 looked fine. So,
But they're all going, but both points were going through the 0, I guess. I don't know how to say it, but the order pair was both of the numbers were 0.
right.
So I guess, am I understanding, it would be infinity, correct?
Well, let me ask you this: Do you mind if I let the class see? Because I could share the screen, but I was
No,
trying to.
no.
Okay.
No, that's fine. Please
Okay.
do, because I need all the help.
All right. So long as you're okay, then we are good. All right. So let's go back to number 3. You guys can see it now, right? So number 3 looks fine. From what I see, not so sure what the problem is here. So that one, I thought I could. I might have to go. I might have to go into another one. I can adjust the score. There you go, right there. It must have changed the outline. Okay. So I gave you that point. So now let's go to number 5. Now you were right with your intercepts. X, both of them are in origin. So, but this one though, notice the graph is a little different. They do go through the origin. You do have your graph going through the origin, but the line is not the same. So how did you get your second point?
I don't know. I mean, I can't remember now.
So
I
let's
can't
do.
remember now, but I just used these, whatever they
Mm.
gave me in the part 1 and 2, and was I not supposed to graph the 0 and 0?
No, you
The
did. No,
two.
no, that was fine. I'll show you what. I'll show you. So this graph or this equation was 3x plus y equal to 0, I believe. Let me make sure. Yep. So 3x plus y equal to 0. So you were correct on your y-intercept, x-intercept is 0, 0. So you have 1 point, but of course, in order to graph, you need at least 2 points. So what you would do is just choose an x. Let me see. Any x. So you would just choose any x to plug into your equation. And then find the corresponding y value. So if you decide to let x be equal to 1, then you will plug in 1. And solving for y, you subtract 3 from both sides. Y is equal to -3. So that means the ordered pair is going to be 1, -3. And that's just any point, any x would have done that for you, would have created a line, a point that's on the line.
Oh,
Yeah.
so I had to pick my own point to find and then plot.
Yes. And the only reason that had to
Okay.
happen is because your x-intercept and your y-intercept was 0, 0. And so you
Okay.
needed a second point. Yeah.
Okay.
Yeah.
Are
You
we gonna
sound.
have are we gonna be able to have the formulas in front of us?
I have to check with Mr. Davis, and I can text him now to see if he'll respond on how he does the testing for you guys. So let me text him.
Because I
I'm listening.
Okay, because I'm about to say I see the test on the Math Connect, so I didn't know if we were going to be able to do it home, and I can have me a little cheat sheet, or I'm gonna have to go to the lab center, and
Look,
I'm not
hold
gonna be
on.
able to have nothing.
You cannot use the word cheat while you're being recorded. What are you doing? You just messed up and
well,
compromised the whole operation. No, I'm just messing
well,
with you.
no, I'm asking because in my previous class we could have a cheat sheet for the
Right.
formula, but we weren't able to have notes, like side notes. Like they
Right.
gave us the formula, but no like side notes to guide you.
Right.
So
Let me so I'm gonna text Mr. Davis right now and see how they are doing the testing for your class,
okay,
and see what the stipulations are. And last time he texted me right while we were in class, so hopefully he's still free and do it like he did last time, and I'll have an answer for you before we close out.
okay,
So, and I saw your other classmate. I saw you. saw your question about timing of the test. So give me 1 second. Let me go ahead and text Mr. Davis.
And by the way, what my last teacher did when I was in ATC, he said we're going to do a brain dump, which is basically write all the information that we have on a sheet of paper, and that was our cheat sheet.
Well, I normally I do certain things like that too, allow a cheat sheet and all the stuff like that. But with this type of course, um, they're kind of more stringent on how they want you to do your testing because they're trying to assure that you have a secure foundation when you go into the more credited classes, because those classes, depending on your teacher, may not give you anything. So they want to make sure that it's in there, in there. You know what I mean? So hold on.
And Professor Tucker, I was wondering if I could stay a little bit after class to tell you about the test.
Okay. All right. Mm-mm-mm.
So, how's everyone doing today?
I guess that means it's a rainy day.
Wonderful, wonderful.
The crickets spoke. All right, so yeah, so are there any other questions as far as reviews are concerned? Anybody have any problems they wanted to see before I go do something else? Now, as far as when you take your test, as of right now, it's pretty much on your time. You contact, let me do this, stop my share. Well, I guess I didn't need to do that, just need access to the chat. All right, so when you're ready to take the test, and like I said, I'm waiting on him to respond to me now, Mr. Johnny Davis. That's JL Davis at tcc.edu. So the testing center, that's the man that's over the testing center. Not the general TCC testing center, but the math lab testing center. So he's over the testing and tutoring labs. Also, if you need tutoring or you want tutoring outside of me, you can contact him for that as well. They have tutors, and like I said, they do the testing, and they will tutor and test you through Zoom, so that you don't have to go in or anything like that. But that is his contact information. When you're ready to take the test, and I would suggest that you don't take too long to get ready. You would contact him. Yes, sir.
Where is the contact information? I don't see it.
It's not in the chat.
Oh, there it is.
Yeah.
Okay.
Yeah. Chat session.
I
I mean, not chat session, but
had to figure out what button to click on.
say that one more time.
I had to figure out what button to click on.
Oh, okay. All right. When do you want us to take the test by? As soon as possible. We have last class. We closed out the information in chapter under the first test. So next new thing we talk about will be us preparing for the next test. We will be preparing for test 2. So you want to knock it out as soon as possible. I haven't put a date out there yet, but and because I may not even close it out, just give you the opportunity to just go and do it. You just don't want to procrastinate too long and have this stuff just lingering out there, because of course we're going to cover more things. So you want to go ahead and knock this stuff out as soon as possible.
Professor.
Yes, sir.
We can't get you to monitor the test as we do it. Can we contact
See, the only thing about it is we already have that set up with him. Now, I can do it in special cases. I'm not saying that I cannot, but you're talking about, let's say if I have 30 students,
Gotcha.
Everybody's in the individual spot. So now it's a possibility, worst case scenario, of course, me proctoring the test 30 different times at 30, you know what I mean? So now special cases, most definitely I try to accommodate. But right now, I would like for us to try to go through the testing center because that's what they get paid to do. You know what I mean? Um, if I was going to do a class thing, it would be multiple people at one time, and we can figure it out if it comes down to it. That's why I'm trying to see what type of situation he has going on with the testing center. Now, if it does seem to be more problematic than necessary for us, then what I can do is schedule a day for everybody who's available or ready to take it at that day. Y'all show up. If it's only 5 people, if it's only one person, if it's 10 people, then great. And then if you don't show up on that day, then you have to go through the testing center. So we can do it like that. So let me just iron out these details with him, and then if you don't say that again.
Am I breaking up?
Yeah, you going in and out.
Let me unplug this. Can you hear me now?
Say it one more time.
Can you hear me better?
Try it one more time, right there.
Can you hear me?
You still going in and out, but I can hear you. Just you go ahead. I think I'm good.
You good? My question is, how does we email him, say, hey, we want to take the test, and he emails us back a link or something? How does it work?
Yes. So you tell him you're ready to take the test. He'll discuss with you what times are available. Try to match it up with your schedule, and then he will shoot you, Zoom information just like I gave you. And then from there, he will give you or tell you like to bring your ID, make sure your video is available to be seen. That's same type of stuff that I would tell you to do. And you take the test. You come in during that time, type in Zoom information. You may have a password, and then you go ahead and take the test.
Okay. And what if they don't show up on their end? What do I do?
Well, shoot, man, they're getting paid to show up. They better show up. Right. That hasn't happened yet. So if it does happen, of course, you can just let me know, and we'll move accordingly.
All right, then take a picture of the screen and send it to you.
Yeah, that'd be cool. Yep. All right. Anybody else?
To review over the weekend, and hopefully sometime next week take the test.
Okay. Sounds like a plan to me, sir.
If I have any questions, I seen it. Is I just seen your email over the weekend?
Yeah. I would have answered your other email, but you said go over it during class. So I figured that question would help others. You know what I mean?
The biggest problem that I have is I have to keep retrying to get it right, and you can't do that on a test.
No.
So test ain't gonna tell you if it's right or wrong. So
it'll tell you if it's wrong.
yeah, it'll tell you it's wrong, but it won't give you a second chance.
Right.
Sorry for taking up too much time, folks. I should have waited out the class. I apologize, folks.
I think it was good information. Let's see.
And the
So,
question that people was asking about the formula sheet, that's not really a cheat sheet. You're just writing down your formulas.
well, I guess it depends on how you set it up. Like me, if I were to let you do some type of sheet, then what I would do is just say, okay, on the front sheet. Well, this would be like for a face-to-face class. I mean, of course, it's hard to monitor that you sitting at home. You know what I mean? But if it was a face-to-face class, I would say you get one front sheet, write whatever you want to write on it. Because if I say just write down these formulas, like I'm not going to walk through I try to be realistic. I'm not going to walk through the class and say, let me see what's on your test. That's taking up more time, or see what's on your paper. So I would say front half, you can write whatever you want on it, and then just go from there. So, because even if I say don't put all the formulas up there, you still could write down whatever you want to write. So, if I were to do it, it would be a little bit of a cheat sheet. I could. Let's see.
Okay, Professor Tucker, I have one more question.
Yep.
It is in section, hold on. It's in section 5.4 and it's number 8. Because I tried that all 3 times and I don't know how they got that answer.
All right. Let me close this out. So 5.4, number 8.
And when we email the lab, CC you on the email?
You can, but I don't necessarily have to get that, you know. Just that email trail, that paper trail, is fine because if the issue comes up, then you can send it to me then, you know what I mean?
Yeah.
But as far as the transaction of you guys setting that up, I don't really need to know. All I need to do is see the final result and then maybe know if there was a problem that occurred, you know.
Gotcha.
All right, so you want to find the slope.
What I'm concerned about is, as soon as I get out of class with you, I don't have all these questions. I'm like, damn, why I ain't asked while I was in class? Because I can't think.
Right. Miss Spence, this is the one you were talking about? Did I lose
I'm
her?
sorry, I was going from screen to screen.
Oh, okay. I was like, oh no, did I lose her?
No, I'm trying to go from screen to screen. No, it doesn't look like it. The same one. It's section 5.4, question number 8. It's
Let me
three
see. Did I
three
pick?
sevenths, 4/5, and then the next pair is 1/4, -6/5.
Okay,
And
so
then you have to find the slope that
but
passes through.
okay, yeah. So I just got different fractions, but it's just the same. But it is the same.
Oh, okay.
Yeah. So yeah,
Same
I'm gonna get
concept. Okay.
yeah. So because I'm gonna get different numbers. Um, so now, did you want me to do those numbers specifically though? Did you?
No.
Okay.
That's
Okay.
fine. I can get it from this one.
All right. So we're still leaning on this relationship, y2 minus y1 equal to, or not equal to, but over x2 minus x1. And so my y2 is -2/3, y1 is 1/3, x2 1/8, and we got 1/4 for x1. All right. So now what we need to do is subtract our fractions up here and subtract our fractions down here separately. So -2/3, this is my numerator, -2/3 minus 1/3 is -3/3, which would be -1. Denominator. And don't forget, when it comes to adding and subtracting fractions, we need a common denominator. And that common denominator for this second set would be 8. The first set, we didn't need it because both of them were 3. Down here, my LCD is going to be 8. So the first fraction has an 8 down there. Second one does not. I need to multiply top and bottom by 2 so that I can have 8 in my denominator. But remember, whatever's in the bottom, whatever you do to the bottom, you have to do to the top. So if I say I'm going to multiply 4 by 2 down bottom, I need to multiply the top by that 2 as well. So now I have 1/8 minus 2/8, which is going to be -1/8. All right, any questions before I
Okay.
keep
I
going?
didn't find the lowest common denominator. That's what I didn't do.
Oh, okay. Yeah, that'll do it to
Especially
you. Yes, sir.
when I'm always doing my subtraction old school, where you stack 1/8, then you put 1/4 on the bottom.
Okay.
When you do the times two, you multiply by 2 because it's a multiple of both those numbers.
No, well, you're asking yourself, okay, first of all, you're going to establish what is your LCD. Your LCD, your common denominator, your least common denominator. what denominator are you going to turn both of your fractions into in order for you to be able to add or subtract them? You know what I mean? It didn't matter in this first one because both of them had a denominator of 3. In the second one denominator was 8, the other one was 4.
And I
So in
always do
order,
it the old-fashioned way, but I'm trying to do it the new way.
oh well, this is no. Well, now if you're talking about just setting it up this way,
Yeah, I always do it that way.
oh, it's the same process.
Okay.
Same process. I just have it set horizontal. You talking about setting it up vertical? It's the same thought process. You still need your denominators to be the same.
Okay.
So you need to figure out, okay, what's the smallest number I can change both of them into in order to have the same denominator. And so 8 is there, but so that's fine. I can change the 4 into an 8, so I don't have to manipulate both of them. You know, if I had 1/2 minus 1/3, I would need to change both of them into 6.
6.
Right. So, so since I said my least common denominator is 8, then you ask yourself, what do I multiply to 4 in order to get 8? And that'll be 2. Whatever you do to the bottom, you have to do to the top.
Got you. Another question about the assignments. What tripped me up is dividing when we have to get those problems. I forget what section. I don't know if it's at 4.
Mm-hmm.
The 7. I'm just using it as an example. 7 on the outside, and 7 on the bottom, and give them all the same denominator. I'm just using it, just speaking in general.
Okay.
But that's what trips me up.
So you said 7 on the outside, and then we're not finished with this problem, so we'll come back to it in a second. I just want to see what you're saying. So 7 on the outside. Are you talking about 7? You said 7 on the bottom like that, or?
When we have to do the long equations, I forget what I should have came prepared, but
Yeah.
it just hit me while I was doing this. I think
Right. Yeah. So this is what you do. If you find one for me before we close out,
okay.
then you know I'll do it. But if not, you know we already talked about how you can email me. Yeah. So let's go ahead and finish this. This is -1 divided by -1/8. This division sign is the same one as this one. So once again, I went from writing it vertically to horizontally. And the reason why I did that is because whenever you're dividing by a fraction, you need to multiply by the reciprocal. So the division changes to multiplication. That 1/8 changes to 8/1. And so -1 times -8 is just +8. All right.
I'm ready. This is from 4.3, further solving linear equations.
Mm-hmm.
7q minus 5.
Is it 7 cubed?
7q.
Okay, Q. Okay, the letter Q. -5.
Minus 5.
Mm-hmm.
Minus 3q plus 4. That's in the numerator. Equals 1. The denominator both has 7.
So now look at my screen though. So am I putting a 7 under that or
Both of them has 7.
like that?
Yes.
Okay. Nothing under the 1?
No.
Okay.
But when we multiply, that's what trips me up with this sometimes.
All right. So if you want to get that 7 out of your denominator, and now there's a few key things here. So let's make sure we're good on what's going to happen. Matter of fact, I'll rewrite it down here so I can leave that up. I want to first multiply each term by 7 so I can get rid of the denominator. Yep. All right, so that's the first thing we want to do is multiply each by 7, even if it doesn't have a denominator. In order to keep your equivalency, you have to multiply everything by the same number. So that 7 has to touch or affect everything in the equation, even that 1 all the way on the right. Okay? So what that allows to happen is the 7's cancel. Now, this is the step right here that a lot of people make a mistake on. This negative is not negative 3q. That negative applies to that whole numerator. And so a lot of people forget that this is the actual scenario that you are presented. That negative needs to be applied to the 3q and the 4. So this negative is sitting out front, is not attached to the 3q necessarily. So it has to be applied to the 3q and the 4. So now you distribute 7q minus 5 minus 3q minus 4 equals 7.
Combine like terms.
Yep. So it would be 4q minus 9 equal to 7. Add 9. And then divide by 4.
Thank you, Professor.
Not a problem, not a problem.
We're not gonna have any equation on the test dealing with perimeter, are we?
Is it in your homework? You gotta refresh my memory.
No, it's not in the homework, but it's
Yeah.
in the book itself.
Yeah, I don't think so. Yeah, I didn't think this class actually went into perimeter.
All right.
So you should be fine. All right. So this next section, first section out of 6.1 is talking about exponents. I thought we've already talked about exponents, but so it should be more of a review, but it wasn't heavy, so I was going to go ahead and at least touch on exponents today.
Hey, I forgot to tell you, Professor. It's to Jennifer. In that formula thing, when you're doing graphs, they got that feature where you have to do it exactly. And you plug your numbers in, and it'll do your points for you exactly.
Oh yeah.
Yeah, I didn't remember. I sent you an email saying I don't know what I'm doing wrong. And you showed me during the class. You put my screen up. It was off by like a hair.
Right.
But it's a feature where you click on a button and you just plug the numbers in.
Oh, okay. Okay.
She was talking about her problem, and I was like, okay.
But they don't give that to you every problem. Some of the problems you have to just plot it yourself, and then other problems, I guess, when they're saying you should be using that feature, they give it to you.
That's weird.
Yeah, Professor.
Well, sir, I did not create the program. I didn't even choose it.
What's up with that, Professor?
I wish I did have power like that, sir.
And I knew I was right until finally I sent you that email that I told you disregard because I figured it out.
Mm-hmm. Got you. Well, that's part of the process when you go through. Those are things that you remember when you figure it out on your own. You put time in and sweat, blood, sweat, and tears. You know how they go.
And pain and agony.
Yeah, you never forget it. All right, so looking at exponents, and just to make sure we're good on what they're asking for of you and for you to do, 2 cubed and 3 squared. Even though we have the same two numbers, there are different things going on here. This bottom number that's printed in usual size is considered your base. And then the number superscript is your exponent. All right. So what this means is that you're going to multiply not 2 times 3, which a lot of people make that mistake because they're getting their flow to get rolling. They see 2 times 3, 2 times 3 is familiar. They write 6, but that is not it. This is 2 times itself, 3 times, which means you would have 8 as a result. And 2 cubed, 3 squared, of course, are not going to be the same. This would be 3 times itself 2 times, which is 9. And I wrote this, I should have wrote this better, right, by using. Another exercise you can see, right, by using exponents. We have 2x times 2x times 2x times 2x, so that would be 2x to the 4th power. As a matter of fact, let me ensure of something real quick. Before I tell you this answer. See if they want it as simplified as possible. Are you serious? All right. Try it one more time. That's a 4. Okay. Okay, so they don't want you to do that. Okay, so I was going to simplify it further. That's all they want for the answer. They don't want you to simplify it further. So that's good enough. Now, there will come a point in time where you will have to simplify this further. And when that happens, that 4 of exponent is applied to both pieces. 2 to the 4th, x to the 4th. 2 to the 4th is 16, x to the 4th. So both of these answers represent the same thing, but the problem I just saw in your homework, this was what they asked of you. That's all they asked of you.
So you would keep the 4 at the end, even though you have multiplied it 4 times, you would still keep it connected to the x?
So now what this says here, this one right here, and we're going to get into that in a second. The difference, that's the difference between 2x to the 4th with parentheses and 2x to the 4th without the parentheses. Here, for, let's say, exponent of 4 is applied. So that's the difference between having parentheses and not having parentheses. The exponent of 4 is applied to 2x when you have parentheses, the whole 2x. In the second one, when you don't have parentheses, the exponent of 4 is only applied to the x. So when we go back to the 16x to the 4th, that 4 was already applied to the 2. That's how you got 16. We don't know what x is. So what this is saying is that once you figure out what x is, you can plug it in, and then you can apply your exponent of 4. All right. So the exponent of 4 is only applied to the x if you don't have parentheses involved. Same thing as if I have x, y, z to the 5th power. Here, x, y, z, and I put x, y, x, is affected by the exponent. So if I have x, y, z to the 5th power with parentheses, the x, y, z is affected by the exponent in the first one with the parentheses. In the second one without the parentheses, only the z is affected by the exponent. All right. Questions on that before we do another one? So that's a great segue into the next relationship or the next situational scenario that a lot of people, mishandle, I should say, is once again looking at the parentheses and what the exponent affects when you have parentheses and what it affects when it does not have parentheses. This one right here without the parentheses, a lot of people make a mistake and they square the whole -4. But if you look at what we just finished mentioning, what's being squared here is not -4, it's just 4 because there is no parentheses. And the next one, because of the parentheses, -4 is being squared. So that's -4 times -4, which is +16. If we go back to the next one, we have -4 times 4. That negative still sitting on the outside, so that's -16. So that negative is never affected by the square because those parentheses wasn't used to incorporate the negative as a part of the exponent application. All right, -4/5 cubed. That's just -4/5 times itself 3 times. -4 times -4 times -4 is -64. So 2 of your negatives would cancel, negative to negative cancels, but you still have 1 left. So your answer is still negative. And then 5 times 5 times 5 is 125.
So we wouldn't just leave the 5 as a 5, we would actually multiply it.
Yes, that's the difference between adding and subtracting fractions versus multiplying and dividing. Yep. So when you multiply, let me use another fraction. Let's say if I go 2/3 times 4/5. When you multiply, you do multiply across. And that'll be 8/15. Now, if I'm going to add them, though, I need common denominator. All right, so we say that our LCD is 15. That means I want both of my denominators to be 15. Now you have to ask yourself, what times 3 would turn into 15? That'll be 5. Whatever you do to the bottom, how to do to the top. So that'll be 10/15. Then you're looking at 5. You're going to multiply it by 3 in order to turn it into 15. Once again, whatever you do to the bottom, you have to do to the top. That's 12. So now that we have common denominators, we can add our numerators. But like you mentioned, when it comes to adding and subtracting fractions, we keep that denominator the same. And that will be our answer. All right, let's see if I can.
Professor, I got a question.
Mm-hmm.
What's the best way? I know each individual has to review their own way. What's the best way you suggest to review all this material for the test?
Let me see. Best way, because really it's all about practice. I would say, is there a review up? Did he post a review?
I don't see a review.
Let me see about making a review to help streamline your studies. And we'll do it like that. So if you don't see any type of review posted, I guess by Sunday or something, or give me Saturday, end of Saturday, then shoot me an email to remind me.
Okay.
To try to create one for you guys.
You'll post a review by Saturday?
Yeah. Just shoot me an email to remind me.
Will it be in
Can you move?
be in Canvas?
No, it would be in Connect Mail.
Okay.
If someone else was
Can
saying
you?
something.
Oh yes, I was just asking. Can you move it up just a
Oh,
little bit?
I'm just writing them all down, and then I'm gonna go back through them. So
Oh, okay.
yeah, right now I'm trying to do them off memory before I have to go find them in the book. So so I'm just trying to write them all down. So let's see. Next one, I think that's good.
Then if I have any problems with the review, like these professor, these are the ones that got me stuck. Then I knock those out, then I roll right into the test.
Yep.
Thank you, Professor.
Not a problem. was 9. I think I am missing 1. Am I missing 1? Anyway, if it comes to me or if I see it, then I'll let you guys know. All right, so exponential rules. Whenever you multiplying two terms that have the same base, you're going to add your exponents, and we're going to do some examples to emphasize the rules. So you don't have to worry about that. We'll do that in a second. But if you multiplying bases, same bases, you will add your exponents. If you're dividing, then you subtract your exponents. If you have two different bases, and number 3, if you have two different bases, but you have them raised to an exponent at the same time, you can apply that exponent to each term. So it'll be x to the m, y to the m. Same thing happens with division. X to the m, y to the m. All right, so x to the negative m, if I want to write it as a positive exponent, I would drop it down to my numerator. If I have a negative exponent in my denominator, I take that and what it's applied to and bring it up to the numerator in order to make it positive. X over y to the negative exponent. That negative will make you flip your fractions, and that leans back on these two rules. Anything to the first power is itself. Anything to the 0 power is 1. Hold on, I just want to make sure I'm not missing one of the rules. Thought I always had 10. Might be thinking about something else though.
What was 4? Thanks.
I think I just saw it. So you got number 4? You good?
Yes, I'm good.
Okay. The 10th one's the power rule. So we got x to the m raised to the nth power. I shouldn't have wrote it over there. I don't have room. Yeah, I didn't write that one. Yep, that should have came at number 4. Okay. All right. So x to the m raised to the nth power. Whenever you have a power raised to another power, then you multiply your exponents. Once again, just like I've mentioned before, when it comes to these type of things, try not to be on the mindset of committing them to memory. You should be committing them to usage. So you want to get the practice in, so you're not necessarily remembering these rules, but you're just applying the rules. And that's where you want to get to. You don't want to be sitting around trying to remember these because it may cause more stress than what it would be if you were actually putting them to work through repetition. And that's what you want to look to do. All right, so we're not going to get through all of them today. We'll come back next class to finish off using these, but let's do a few of the first few. All right, so looking at the first rule, if our bases are the same, then we just add our exponents. Reason being is because in this first one, let's look at w to the third power, w to the fourth power. W to the third power is w, w, w. W to the fourth power is w, 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 w. So altogether, we have 7 w's. And so that's the foundation of what you're doing here. You're taking a shortcut. So that's just going to be 3 plus 4, which is w to the 7th power. So whenever you have your exponents with the same bases, you're going to add your exponents. All right, so next one, that's just going to be 11 plus 8 for your exponent, which is 2/19, 2 to the 19th power. Next one, we have y to the 9th, and y to the 17th that we're multiplying. You have your exponent of 1 here. Remember, we talked about it in one of our last rules that if you don't see anything there, there's some, it's a 1 there. So that's 1 plus 9 plus 17. That's 27. All right, last one like this. So we have a b to the 5th, a cubed b to the 8th. And so we'll couple up the ones that are alike. And add your exponents. So that's a to the 4th, b to the 13th. Questions? One more, and then I'll close you guys out.
Did you hear back from Mr. Davis?
He did not respond. So I'll just make sure that as soon as I get information from him, I will let you guys know what he says. All right. So when you're dividing, when we're multiplying, you're adding your exponents. When you're dividing, you're subtracting your exponents. So this would be t6 minus 4, which is t squared. This is 5 to the 10 minus 8, which is 5 squared, and something like 5 squared, it would expect you to go ahead and multiply out, which is 5 times 5, and that's 25. So remember, before we had 2 to the 19th power. That's not anything they would expect you to do. But 5 squared, they would expect you to go ahead and knock out. One more. Same type of thought process. Y to the 15th over y to the 8th. Subtracting your exponents. And that's y to the 7th. All right. So those are your first two rules. We'll look at more rules on next class. Questions before we look to close out? All right. So I will see you guys next class. Have a great weekend. Be safe. See you on Tuesday.
And the review on Saturday.
Review on Saturday?
You say you was gonna post it on Saturday?
Oh yeah. I will look to create that review so that you guys can look at it. Yeah, no later than Saturday. And like I said, if you don't see it by Saturday evening, shoot me an email and to remind me, and I'll put that up.
Thanks, Professor.
Not a problem, sir.